Well, let's continue with our discussion of physical geography in the Southwest. And in this particular lecture, I want to focus on weather and climate in the region. And let's do three things here, really, which is first, I think it would behoove us to kind of be able to see the deserts of the Southwest of our region here in a global context and sort of understand what some of those larger factors are that shape climate in any particular place. Then let's look at precipitation patterns across the region. So we want to understand how precipitation patterns change as we move through the Southwest. And then last but not least, because it's such an important season, is to understand how the monsoon seasonal change in the summer affects weather in the Southwest. It is an important season, and it does really kind of, it's not unique to the Southwest, certainly not in a global context, of course, but there are other parts of the U.S. that experience this kind of monsoon shift. But one of the reasons why it's so important in the Southwest is that being in an arid and semi-arid environment, those summer rains that we get are a really important shaper of the climate and landscapes of the region. So we'll talk about that in particular. So remembering back to your Introduction to Physical Geography courses and talking about climate, you remember that there are several factors that can influence the climate of any particular place. And these would be factors such as your latitude. Are you at a far northern latitude, or are you closer to the equator or to far southern latitude? Are you in a place that's located close to a large body of water, such as an ocean, or are you far inland from an ocean? What is the elevation or altitude of the place that you live in? Of course, Phoenix, at an elevation of about 1,200 feet, 1,100 feet maybe, has a climate that's very different from Flagstaff, which is at an elevation of 7,000 feet. And oftentimes there's a 30-degree temperature difference. And also the topography of an area can impact your climate as well. So this would include, for instance, places where you might have a high mountain range that blocks moisture, that might block particular weather patterns. And so on one side of the mountain range, on the windward side of the mountain range, you'll have a lot of precipitation, maybe a lot of rain and snow that falls. But on the other side of the mountain range, on the lee side of the mountain, you'll have a really dry climate. And the rain shadow effect that makes most of Nevada, the state of Nevada, a desert, is really pronounced. If you think about the climate of California versus the climate of Nevada and the Sierra Nevada mountains that separate those two and cast a long rain shadow across Nevada and Utah, really. So we call those factors your latitude, continentality, how far you are from the ocean, elevation, and then, of course, the topography of a particular place. And then there can also, of course, be effects associated with ocean currents, sort of whether or not, if you're close to an ocean current, if you're close to the ocean, whether or not you have a cold ocean current or a warm ocean current. And there are, of course, other factors as well. But those are some of the basics. The climate of the Southwest, as we know it today, the arid and semi-arid climate of our region, really fits within the larger kind of arid and semi-arid climate belts of the region, of the world, excuse me. And so this is something that we can see when we look at this map of the world and we look at these rough climate types. Notice the semi-arid and arid climate types and notice their distribution across the surface of the Earth. At about 30 degrees north and 30 degrees south, we often find these deserts. Now, it's not to say that every single place at 30 degrees north or 30 degrees south is a desert, but if you look at our deserts in the Southwest here, Arizona, New Mexico, and northern Mexico, and then you follow that line of latitude roughly over to northern Africa, the Middle East, you'll see arid regions there. And also, if you look at 30 degrees south, of course, you find the Atacama, Kalahari, and the arid regions of Australia. And so our deserts here in the Southwest and our semi-arid landscapes as well fit within this larger pattern, this pattern of arid and semi-arid landscapes at about 30 degrees north and 30 degrees south. Now, if we just left it there and we just said, well, great, the Southwest has an arid and semi-arid landscape, we really wouldn't be getting into the nuances of precipitation patterns across the region. And so let's look a little more closely now at those precipitation patterns. Here's a map of Arizona showing average annual precipitation from the Arizona State Climatologist Office. And of course, the darker blues indicate greater precipitation in a year, and the lighter blues indicate less precipitation. And so hopefully, having done the presentation on physiographic regions, this map makes sense to you. You can see why certain areas get more precipitation and other areas get less precipitation. We can see in the northeast part of the state a large quadrant there that's getting relatively little precipitation. It's falling between maybe 3 and 11 inches of precipitation. Remember our definition of a desert, an area that generally gets about 10 inches or less of precipitation, and our definition of a semi-arid place, which generally gets between about 10 and 20 inches of precipitation in a year. And so you can see that the arid and semi-arid landscapes of the Colorado Plateau in the northeastern part of the state, and you of course see the mostly arid landscapes of the Sonoran Desert in the western and southwestern part of the state. Now notice, of course, that there are areas on this map that are neither arid nor semi-arid. In fact, they get more than 20 inches of rainfall or 20 inches of precipitation in a year. In fact, even more than 20 inches, probably more than 30 inches in some cases. And these are places that are higher elevation, and these are often the mountain ranges. So you can see the effect of the Sky Islands region in southeastern Arizona. You see the darker blues that kind of extend down to the New Mexico and Sonora border there. And you can no doubt see some of the high mountain ranges like the Chiricahua Mountains, for instance, right in the bottom right corner, the southeast corner of the map there. So you can see those high mountain ranges. Remember, those are the Sky Islands, and those Sky Islands, being high mountain ranges, receive more precipitation in a year than the surrounding valleys, the surrounding low valleys. But you also see this interesting pattern across the midsection of the state. And again, remembering back to our physiographic regions discussion, you can see that this is essentially the transition zone, where you're getting high amounts of precipitation as well. And if you look in the far eastern part of the state there, you'll see the White Mountains, for instance. That's the dark blues. And then you can also see the effect of the San Francisco Peaks as you move up toward Flagstaff and some of the other high mountains of the transition zone. The transition zone is so important for this reason, where we have these high mountains, because it's the source of so much precipitation in Arizona. And in many cases, this is coming in the form of snow that falls in the winter. So it creates snowpack, which melts throughout the summer and feeds rivers and feeds creeks throughout the summer, and it's really important for that reason. Now, go ahead and study this map on your own. You'll want to know those patterns. But I want to show you some even more nuanced difference, not just in the sort of annual picture of when precipitation falls, but let's look at a more seasonal picture. Let's look at the seasonal variation of which areas get precipitation and at what time of the year. So another chart again from the State Climatologist Office showing our average February precipitation. So we can take this as being winter precipitation. And notice the patterns here. So take a look and you can see roughly which areas are getting more precipitation and which areas are getting less precipitation. And some of those patterns are really familiar to the overall annual picture. We see some of the mountains of the transition zone, for instance, logging more precipitation, and then of course the Colorado Plateau and the Sonoran Desert getting less. But I want you to take a look at this map closely And I want you to compare it to the next map, which is going to be average precipitation in August, and see if you can find any differences. So again, this is the August precipitation map. Notice where the colors are the darkest, where we have the darkest blues, and where we have the light blues. And I'm actually going to kind of toggle back and forth between the August map and the February map. So again, here's August, going back to February. And again, here's August coming up, and going back to February. Okay, well, one of the first things that you'll notice, and it's an astute thing to notice, is that our data classes on the legend, so to speak, on the bottom left there, they're not the same. So you can't really make a one-for-one comparison to these images because they're indicating sort of different data classes. So that's one thing to understand. However, if you look closely, you can find some differences in the two different maps. And again, here's February, and here's August. Generally, what you could say here, looking at these precipitation patterns, is that, of course, there is a sort of overall annual picture, but in the south and east part of the state, most of the precipitation comes in the form of summer precipitation. And because it's coming in the summer, it's most likely going to be coming in the form of rain. So you see that particularly like in the Sky Islands region there of southern Arizona and southeastern Arizona. They're getting much more precipitation in August, if you look at this map, than they are in February, for instance. So you see a big difference there. So you can see in the southeastern part of the state, greater precipitation in the summer in August than they receive in the winter or in February. Now, however, let's take a look at the northwestern part of the state, up along the Arizona Strip, the far northwest corner. If we look at February precipitation and the colors there, and we compare that to August precipitation, the contrast is perhaps not quite as marked there, but you do see a difference. In fact, here's February, again, looking at the northwestern part of the state, and here's August. So certainly some parts of northwestern Arizona are getting more precipitation in the winter than they are in the summer. Or maybe it's more accurate to say that there's a much more even distribution of precipitation in the northwestern part of the state between August and February, between the winter and the summer. Let's take another look at that with some specific climographs from two different locations in Arizona. The first one being Kingman. And Kingman is located roughly in northwestern Arizona. That's the star that you see in the northwestern part of the state, the upper left corner of the state. Whereas Douglas is located in the far southeastern corner of Arizona, right on the Sonora border, and you see that star down there at the bottom right of the map. That's Douglas. And these two charts are showing climographs, or essentially they're showing you temperature over the course of a year for these two places, and they're showing precipitation over the course of a year. And again, the first thing you'll want to recognize is that the scales aren't the same. So the scales on the y-axis there for precipitation amounts are not the same between Douglas and Kingman. And you can see that there. And in fact, you can see pretty clearly then that Kingman is much drier than Douglas overall in its amount of precipitation. But again, if you look at these graphics closely, you'll see how Douglas has this significant precipitation signal in the summer, in July and August. And they get most of their precipitation in July, August, and September. Some in the winter, of course, but really most of it's coming in July, August, and September in the summer. Again, if we look at Kingman, we do see that August is the wettest month, but it's followed pretty closely by March, January, and February as well. So Kingman, in the northwestern part of the state, has a more balanced precipitation pattern, getting precipitation both in the summer and in the winter. Whereas Douglas has a pattern where they're getting most of their precipitation in the summer. Okay, now this should be familiar to you because we already reviewed this when we talked about the 4 major deserts in North America and their different precipitation patterns. So again, remember this chart? We had Marfa, Death Valley, Ajo, and Reno. And we talked about how Marfa in the Chihuahuan Desert gets most of its precipitation in the summer, whereas Reno in the Great Basin Desert gets most of its precipitation in the winter. And if you were to look at these places on the map, again, you'll see the Chihuahuan Desert there in the southeastern part of the region and the Great Basin in the northwestern part of the region. And what you can see then is actually a much larger gradient all the way across the southwest, starting in parts of West Texas or in Chihuahua in the Chihuahuan Desert. And if we start in the Chihuahuan Desert and we move to the north and to the west, if we just do a kind of diagonal northwest line there, and we go from the Chihuahuan Desert into Arizona, into the Sonoran Desert, and then up into the Great Basin Desert, we could describe a changing precipitation pattern of, in the Chihuahuan Desert, summer wet, winter dry, and then moving across the region until we get into the Great Basin Desert, where we have the opposite pattern of summer dry, winter wet. And then, of course, the area in between, which is Arizona and the Sonoran Desert, where we oftentimes see the dual precipitation patterns. We have both a wet period in the summer and both a wet period in the winter. So in some ways, we can describe Arizona as being in that kind of transition from summer wet, winter dry in the Chihuahuan Desert to summer dry, winter wet in the Great Basin Desert. So this is an important thing to be able to understand in describing the weather patterns, or really the climate, across the larger southwest region. Of course, you would see climate differences associated with elevation, right, where high mountain areas are typically wetter and cooler than the low valley areas, which are oftentimes drier and hotter. You would see some changes as you move from north to south across the region in terms of temperature, but you're also seeing this larger kind of precipitation regime shift as we move across the region from the Chihuahuan Desert, moving north and west all the way into the Great Basin Desert. So many different ways that you can broadly describe, or with a kind of broad paintbrush, you can kind of describe the precipitation patterns across the region. Now, one of the reasons why we see such a pronounced wet season in parts of southern Arizona, southeastern Arizona in particular, in the summer is because of the seasonal wind shift that happens in the mid to late summer in the southwest. And those of you who are from the southwest know this well because we call this monsoon season. And sometimes we mistakenly describe the rainfall itself as the monsoon. And so you've definitely heard this referred to before when we get a summer thunderstorm as somebody saying, oh, the monsoon is here. And really what monsoon means is a seasonal shift in the prevailing wind direction. And we use the term monsoon because the region of the world that we most typically associate with this kind of weather pattern is in the Middle East or parts of India, the Indian subcontinent, where wind patterns shift in the summer, and they shift and start to bring in air from the south, warm, moist air from the Indian Ocean from the south in the summer, and that tends to bring these big rainstorms and causes massive flooding across the region. And we don't get nearly as much rainfall in our region from these monsoon seasonal shifts in the southwest, but we do get increased rainfall. And we oftentimes get rainfall that's associated with these thunderstorms, and it can be quite violent, and it can cause flooding, flash flooding, and a lot of damage at different times. Okay, so here's what's happening. Monsoon means a seasonal wind shift, and typically shifting from a land breeze to a sea breeze. Sea breeze. In Arizona, the desert, what are you talking about? Well, in Arizona, we typically have a prevailing wind direction that's coming mostly from the west, or perhaps the southwest. And in the fall, winter, and spring, we get this prevailing wind direction that comes from the west. So, in the winter, in a place like Phoenix, when we get rainy weather or we get a storm, this is oftentimes a storm that's coming in off of the Pacific Ocean, and it'll first hit California. It'll first come across San Diego and Los Angeles and the Baja Peninsula, and then from there it kind of moves eastward across the region, and it moves into Arizona, and then from there it moves on into New Mexico and maybe up into Colorado, and it just kind of sweeps across the region. And the rainfall that we typically get in the winter is kind of a gentle rain. Oftentimes these are soaking rains. They can be heavy at times, but they typically fall for, we might get a rainstorm that lasts for half a day or an entire day or something like that. And these storms, because they come in the winter, they bring snow to the mountains. So up in the Flagstaff area and the San Francisco peaks, we'll typically get snow up there and in other high mountain areas. Now what happens in the summer is the wind direction, the prevailing wind direction shifts. So it stops coming from the west and it starts coming out of the south. And when it comes out of the south, it tends to bring, it can bring moisture with it. And because it comes out of the south, it sort of comes into the southwest from the south as well. And so as the wind direction shifts, it makes sense then that we're going to see greater precipitation happening in the southern part of the state, or particularly the southeastern part of the state. And one of the reasons for this is because as the wind direction shifts and comes from the south, it tends to bring moist air, or air with different sources of moisture, typically. And so in our region, this could be air that's perhaps coming from either the Gulf of California, as you're seeing with the arrow there, or in some cases even the Gulf of Mexico. And the Gulf of Mexico in particular is a large area, warm body of water, and when air moves in off the Gulf of Mexico, it oftentimes is laden with moisture, and it can bring a lot of moisture into the region. So what we're seeing during the monsoon is this shift in wind pattern, and the winds coming up out of the south and bringing in air off of the ocean Pacific or the Gulf of Mexico that's oftentimes warm and can even be laden with moisture, and it moves into the region that way. Now the rainfall that we get in the summer is typically not associated with, for instance, like a big frontal system that comes in off of the Pacific Ocean and comes across California and then comes into Arizona. Remember, that's the type of thing that we see in the winter. That's where our precipitation comes from in the winter, and that's what's characteristic of our precipitation that comes in the winter. In the summer, what typically happens is that we get our precipitation in the form of thunderstorms. And so remember, we have this shifting wind direction, the monsoon seasonal shift, bringing in warmer, moister air from the south. And as this air moves in to the region, as it moves into the southwest, there are going to be all kinds of things happening. That air can be lifted either through convection, through heating that's happening during the summer. Remember, it's the summer in Arizona. There's a whole lot of heat energy, and there's a whole lot of heating happening that's going to cause air to lift. Or air could be lifting because it's forced up and over a mountain range, up and over a mountainous area. And in both of those cases, when that air lifts, it's going to cool, and it's going to condense, and oftentimes it's going to precipitate, and it's going to cause precipitation to fall. And you can see this happening if you're from Phoenix or if you've spent a summer in Phoenix. Oftentimes, when we get those thunderstorms in the summer, if you look out across the valley, the areas where you'll see the clouds forming in the first place are off on the edges of the valleys along the mountains, and oftentimes on the east side of the valley towards the Superstition Mountains and in that direction. That's where you can see these big thunderstorm clouds start to develop, of course, as air is being forced up and over that topography and up and over those mountains. And what happens when that air gets forced up and over mountains, or when air rises due to heating, it condenses, it forms clouds, and then it precipitates in the form of rain. Remember, this is the summer, so it's warm. Typically, the precipitation is always going to fall in the form of rain, sometimes hail, but oftentimes rain. And those of you who have experienced these monsoon season thunderstorms know that they can be quite destructive because the rain can fall with such force and such intensity that it can cause flooding in localized areas. And you typically see this. This image here of a summer thunderstorm during the monsoon season is pretty indicative of how that works. You can have particular areas of the desert here that won't see any rainfall. It could be even sunny, but then other areas that will get just a ton of rain, soaking rain, that can fall pretty dramatically and pretty violently from these thunderstorms. And what happens is these normally dry washes and rivers that we have in Arizona in the southwest can fill with water and become flooding torrents very quickly. And this is an image actually of Sonoita, Mexico, right on the border with Arizona. If you've been to Puerto Penasco, Rocky Point, you've driven through Sonoita, and this is one of the normally dry roads that goes through the normally dry Rio Sonoita, the Sonoita River here. And we just happened to be there a day after one of these big summer thunderstorms during the monsoon season and completely turned this normally dry riverbed into a flooding torrent. Now in Arizona, they have that stupid motorist law, and they say that if you drive into a flooded wash, you're liable to pay your own expenses for your rescue. In Sonoita, it's a bit more lax, and people have to still get around town. And so what was essentially being set up here was a way to ford the flooded river, and you could walk across it on the bridge there. But if you had a high clearance vehicle, you could just go ahead and drive right on through it. Of course, not recommended most of the time, but sometimes it's a necessity if you want to get through these flooded areas. Okay, be careful driving through flooded areas. Best not to do it, but if you have to do it, there's better ways and worse ways to do it. Having a big semi-truck like this is helpful. I can get you through the water in a much easier way. Okay, that concludes our discussion here of weather and climate. All too brief, I know. There's much more we could talk about in terms of the weather and climate of the Southwest, but that should give you a kind of general overview of patterns across the region, of seasonal changes across the region, and especially this important seasonal wind shift that we get in the summer called the monsoon.